Okay, Shane, I'm sure you noticed in the first assignment sheets, the notes I sent back to you, I put a note on there asking you to show some of your work when you go through these assignment sheets because I really don't have any way of being able to determine what you're having trouble with unless I see some of your work. And what you've done on all these is just wrote in answers, and that doesn't really tell me much of anything, except that maybe a guy can look in the answers in the back of book and copy them onto the assignment sheet. So I really want you to, show some of your work on these things. Okay, looking at assignment sheet number 2 in series circuits, DC. Number 1, we want to know what's going to be greater, the voltage across R1 or the voltage across R2. When we went over the previous assignment sheet number 1, we talked about this a little bit. We said that in a series circuit, the largest voltage drop is going to occur across the largest resistor. Okay, in this circuit, you have R1 is 20 kiloohms. 20 kiloohms is equal to 20,000 ohms. Because when you convert from kilo to the basic unit, you move the decimal place 3 places to come up with ohms. Now R2 is equal to 10 ohms. Well, clearly 20,000 ohms is much bigger than 10 ohms. So the largest drop is going to be ER1. And number 2, which will be the greatest? ER1, ER2, or ER3? Okay, we're going to go resistor by resistor again. R1 equals 27 kiloohms, and that's equal to 27,000 ohms. R2 is equal to 10 k ohms. Converting k ohms to ohms, we move the decimal place 3 to the right. So 10 k ohms is actually equal to 10,000 ohms. Now R3 is 33 k ohms. If we convert k ohms to ohms, we move the decimal place 3 places over to the right, so 33 and 3 zeros is 33,000 ohms. So R3 is the largest one of the bunch here, so that means ER3 the greatest. Okay, let's move on to number 3 now. Solve for ET. ET is the total voltage here, and we talked about it in the last assignment sheet, on assignment sheet number 1, that the total voltage is equal to the sum of the voltages across, or voltage drops across the resistors. So that's going to be ER1 plus ER2. ER1 is 15 volts plus ER2 is 10 volts. So the total then is 25 volts. So ET, the applied voltage, or the total voltage, is 25 volts. Okay, let's go on to number 4. Solve for EA. EA stands for the applied voltage. In this case, we've got 3 resistors instead of 2, but the same concept applies here. the applied voltage is equal to the sum of the voltages across each resistor. So that means EA is equal to ER1 plus ER2 plus ER3. Now let's substitute the numbers in for the symbols here. ER1 is 10 volts, and we're going to add to that ER2, which is 15 volts, and to that we're going to add ER3, it's 20 volts. So 10 plus 15 is 25, plus 20 more is equal to 45 volts. And EA then equals 45 volts. Okay, and finally here we are at number 5. Solve for EA. It's the same idea here. The applied voltage EA is equal to the sum of the voltages, which is ER1 plus ER2. ER1 is 5 volts. ER2 is 25 volts. So you add those together, you get 30 volts. EA equals 30 volts. That's a nice 3, I know. Let's try that again. EA equals 30 volts. Forget about that one. Okay, well, in our next video we'll go on to assignment sheet number 3.